Remember, the question asking for Q. And again, there is no kinetic energy, there is no potential energy, so we can assume the final equation for this is Q delta H. Okay, so in order to get the delta H, we have to find N times the specific enthalpy. And then if we derive for this question, we got the sum up for NH out, okay, minus sum up for NH in. Okay, so this is the final equation that we're going to use. So this is where you will get the total. Okay, N minus H in will be here, N out and H out. Okay, so now our task is to determine H1, H2 and H3. Okay, let's do H1 first. So H1, okay, first we do the hypothetical path that we have learned before. So H1 is acetone. Okay, start with the reference state. Reference state that have been stated here is liquid, 20 degree and 5 atm. Okay, converted to, we know the acetone for, because we are now calculate for the H in, so the inlet for the acetone is vapor, okay, because the inlet is in vapor state, and then the temperature is 65 degree and the pressure is 1 atm. Okay, so this is the main path. Okay, this is reference, okay, which you set earlier. Then this is the condition at the inlet. Okay, now before we can solve, we have to break down this to the hypothetical process path. Okay, we start with, as we learned before, okay, because you see every condition here is different. Okay, so we need to know what is the H1 here. Okay, so we have to do this hypothetical process path. Like we mentioned before, liquid to vapor, then we have to make it the process path. Firstly, let's change the temperature first using the boiling temperature. Okay, we know, we refer to the table B1. What is acetone temperature? Acetone boiling temperature is 56 degrees C. Okay, and then maintain the pressure. Okay, let me take off. Okay, and then what next to be changed is, let's say we want to convert the pressure, okay, to 1 atm. Okay, see, 1 atm. So every single time you break down this, only one condition will be changed. Okay, next, so we can convert the phase into vapor. Okay, liquid, vapor, maintain the temperature 56 degree and 1 atm. Okay, next, have we achieved the main condition? Not yet, so we have to put another arrow. Okay, so this arrow represent for the changes of temperature from 56 to 65 degrees C. Okay, now we have H A, H B, and then H C, and then H D. So it's can be summarized that to obtain the H1, we have to sum up HA plus HB plus HC plus HD. Okay, the calculation will be a little bit longer. but just be careful, do it slowly, step by step. Okay, next, HA. HA, what is the changes in HA? The changes here is involving temperature changes. If you still remember, okay, how to calculate the enthalpy if there is a temperature changes. So we have to use the CPDT, the heat capacity. So here we know the temperature is 56 to 20. So we'll do heat integration, okay, represent of the temperature changes in this HA plus HB. Okay, how about HB? HB, there is a changes in pressure. So if you still remember, the changes of pressure, in order to obtain the enthalpy, we use this uh, formula, which is specific volume times with delta P. Okay, and then next, plus here we have HC. HC here is phase changes. Okay, phase changes. If you still remember, the phase changes, you have to obtain the value from the table B1. So here is liquid to vapor, means you have to determine the acetone heat of vaporization from the table for acetone. Okay, that is for HC. How about HD? HD again, the change is on temperature. So again, we use the formula for obtaining enthalpy with temperature changes. So the T2 is 65, T1 is 56. Again, we got this CP DT. Okay. Now we have to go slowly to see where we can get this CP. Okay. Then for this one, okay, you have to refer CP from table B2. Okay, table B2, and from table B2 you will find acetone. Acetone, and remember this acetone at these stages is in liquid stage, in liquid phase. So in table B2 there is 2 row on acetone part. So one is liquid and another one is vapor. So choose the liquid one, which is you will see the value will be 1, 2, 3 times 10 to the power of negative 3 plus 18.6 times 10 to the power of negative 5 T. Okay, this is how you write down the value from the table B2. Okay, this is for HA. Next is for pressure changes. This one you can refer to page 300 in the new book. Okay, page 300 in the new book, the simplified equation. So the simplified equation will be like this: 1.103 times 10 to the power of negative 4 divide by specific gravity, and then times by molecular weight. Okay, what molecular weight? Acetone molecular weight. So we know that acetone molecular weight is 58.08. Okay, and the specific gravity for acetone is 0.791. Okay, and then times with the pressure changes. So your pressure changes is 1 minus 5 atm. Okay, so this is pressure changes. Okay, P2 minus P1. So this is for HB. Next, for HC, which is heat of vaporization. If you look at the table B1, you can obtain the value is 30.2 for acetone. Okay, next, HD. So HD again is CPDT 65 and 56. Remember, this stage the acetone is vapor, not like the first one which is liquid. This one is vapor. So make sure you refer to the right row for vapor acetone. So write down the value. The value is quite long because you have value for A, B, C, D column. Okay, 71.96, times 10 to the power of negative 3 plus 20.10 times 10 to the power of negative 5 t minus 12.78 times 10 to the power of negative 8t2 plus with 18.20 times 10 to the power of negative 12t3. So it's quite long. So this is HA plus HB plus HC plus HD. So you calculate this. For integration, just plug in into your calculator. Okay. So final answer for H1 is 35.7 kilojoule per mole. Okay.